Let's talk about linear regression briefly. Linear regression is a type of regression model that estimates the relationship between one independent and one dependent variable. Again, an underlying assumption, this is a parametric test because the underlying assumption is that you have a normal distribution, Bell or Gaussian curve, of your continuous data. The slope of the line, so this is going to take you back to some basic algebra from a while ago perhaps, the slope of the line indicates the change in y for a 1 unit increase in x. And you interpret that then by knowing what the units are, and they should always be presented in a table. So if it's age, it might be year. If it's height, it might be an inch or a quarter of an inch, but you have to know what that unit is. So again, the slope of the line interpretation is the change in y that you expect for a 1 unit increase in x. So let's take a look at what that looks like. We looked at this table when we were considering t-tests as well. Got several different things going on here. The second column shows the coefficients from a linear regression model and 95% confidence limits around that, which means we are 95% sure that the true estimate of the coefficient lies between that lower bound and that upper bound. And then that really tells you your level of significance, again, at a p of less than 0.05, because these are 95% confidence limits. When you're looking at the results of a linear regression, you'll see an intercept, and that's the intercept, if you actually had that graphed out, the intercept of the line. And you always have a reference. So when you have linear, you'll see the same thing for a logistic regression as well. You have a reference category. And in this case, when you're looking at temperature, your reference category is cool, and you're going to be comparing warm to cool, hot to cool. And when you're looking at skin reaction after first exposure without sunscreen, your reference group is always burn, never tan, and those coefficients relate back to the always burn, never tan, the lowest category. So again, we talked about intercept, the coefficient, and the 95% confidence limits. You'll notice that the p-values, again, you really don't need a p-value because your 95% confidence limits tell you that. So if they're not overlapping 0 for a linear regression, they're statistically significant at the p less than 0.05 level. And you see that here, the test statistic, and they don't overlap, so that's statistically really highly significant. So where you see that p less than 0.001.